Okay, so welcome to section. This will be 3.2, and this is quadratic functions. Okay, so let's recall. So the graph of a quadratic equation or a quadratic function is U-shaped. So let's consider let's say we have x and y coordinate axes. Maybe I'll go here. Let's say maybe we've got k here, h here. This is the x and y coordinate. Let's say the bottom of my quadratic is down here, and it does something like, oops, let me make that a bit better. Something like so. Actually, do you know what? I think I want to make this a bit steeper. Maybe like that. Okay, I guess I forget that I've got my tools to the left now. Okay, so here's my quadratic, or something close to it. Okay, so notice that it has a minimum in this case, and the coordinate is h for x and k for y. Notice also that this line, which is x equals 2h, this vertical line, there's a mirror image on either side. So mirrored across x equals h. And then we've got this other point. Oh, I keep on forgetting. I can do this now. Let's see. Do this in yellow. If this is C, then there's a y-intercept. Y-intercept at 0, C, because the x-coordinate is 0. And notice that I've shifted the graph. Why do I keep on doing this? I'm teaching an old dog new tricks. We shifted from the origin, h units right. So h units right. And in this case, we've shifted k units down. K units, not kappa, k units down. Okay, so this is pretty much what we have. And so what was the... Oh, I've got it right here. What am I doing? I can do this now off to the left. So what was the standard equation for a quadratic? It was y is equal to x squared. So now, let's say I want that its stretched vertically by a factor of a. So y equals to, let's say we have a x squared. That would imply that's stretched vertically by a factor of a. Okay, now let's say I want to continue with this, say it's still stretched vertically by a factor of a. But now I want that it shifts h units to the right. Well, that's going to be x minus h quantity squared. So this would be shifts h units horizontally. Let me move this up a bit. This is going to be confusing. Let's move this there. Okay. And now let's shift k units. Why do I keep on going up there? Now let's take this, copy, paste, and now let's shift k units vertically. So now it's going to be plus k. So this would be shifts k units vertically. Now if k is negative, of course that means down, right? Okay. So what does that give us? Well, let's expand this. Once again, I can go to the left here. So we have y is equal to a times the quantity. Expanding this will be x squared minus 2xh plus h squared, to which we're adding k. So this is going to be a x squared minus 2axh plus ah squared plus k. So therefore my y-intercept when x is 0, right? The other two terms go to 0. Implies that my y-intercept c, as pictured up here, is going to be ah squared plus k. Okay. Hopefully you're able to see this. So let's let, maybe I should do a different color now. Let's let b be equal to, well, I want b to be the coefficient of x. So that's going to be negative 2 ah. This implies that we can rewrite y as ax squared plus bx plus c, where we've defined b and c as above. Okay, so let's define this formally. So definition. Okay, so the general form of a quadratic function, that's what we're defining, the general form, of a quadratic function is given by f of x is equal to ax squared plus bx plus c, where number one, a is the vertical stretch, is that how you spell stretch? Maybe. Number two, b is equal to negative 2ah for a horizontal translation. Horizontal translation h. Number three, c is equal to ah squared plus k for a vertical translation, k. Okay, so another definition, which is analogous. This is the standard definition, so definition. So the standard form of a quadratic, so the standard form as opposed to the general form, so the standard form of a quadratic function, quadratic, is given by f of x is equal to a times the quantity x minus h squared. Let me draw that a bit better. X minus h quantity squared plus k, where number one, a is the vertical stretch, and number two, maybe I can get myself an extra line here by moving these up. Because I need one more line. Okay, so number two is that h comma k is the vertex. H comma k is the vertex, and the vertex in a quadratic is max or min. Okay, so let's recall. What did we have? We had that b was negative 2ah, right? So b is equal to negative 2ah. So what that means is that we can solve for h. So h is going to be, was h in, yeah. So h, if I divide both sides by negative 2a, is going to be negative b over 2a. And then we had that c, growl, I know, my stomach. So c is equals to ah squared plus k. So that means that we can solve for k, which is going to be c minus ah squared. Okay, but what was h again? So h was negative b over 2a. So we have that k is going to be c minus a times the square of negative b, so that's b squared over Square of 2 is 4. Square of a is a squared. So now one of the a's reduces, and we're left with k is equal to c minus b squared over 4 times a single a. Okay, hopefully that makes sense. Okay, so let's note so the graph of a quadratic is termed a parabola. So the graph of a quadratic function is called a parabola. Okay, so let's consider the following. So let's do x and y coordinate axes. And I'm going to actually copy this at least 2 more times. So let me copy and paste this. Okay, hopefully that's enough. Okay, so now let's say we've got regular x squared. Actually, now I can do this. Nope. Okay, so this is regular x squared. F of x is x squared. Now recall if we multiply by a negative, what happens? So the graph of negative x squared reflects about the x-axis, right? Okay, so this would be the graph of negative x squared. Okay, and then we can move that graph anywhere we like. We can shift it h comma k. So say we have, actually I'm going to copy this. I'll copy this part too. Okay. So call this h and k. And this would be negative x minus h quantity squared minus k, unfortunately. Or actually, no, it's plus k. It's still plus, because I do that last. So there we are. Okay. So note that this up here would be a maximum, whereas this down here is a minimum. Okay, and note that here the coefficient of x, so this is, what color should I use for this? Let's use yellow. This is a 1. So a is equal to 1, which is greater than 0. So what we get then, this implies this is upwards U-shape. In the second case here, we have that a is negative 1. So a is equal to negative 1, which is less than 0. So this implies an upside down U-shape. And we have the same a is negative 1 here, which is less than 0. So that implies this is an upside down because we flipped it across the x-axis when we did that. Remember that negative means we reflect it across the x-axis. I think this will autocorrect now to something nice. Nope, almost. Well, I almost had it. Okay, there we are. Okay, so hopefully this is making sense. So let's recall before I move on. Let's recall. So to find the x-intercepts, so to find the x-intercepts, we set y equals to 0 and solve for x. Okay, pardon me. So for example, so let's plot the following quadratic functions. So plot the following quadratic functions. State the vertex, whether, no, how do you spell whether? Whether it's a min or max, and all axial intercepts. Okay, so number 1. Let's say we have that f of x is given as x squared minus 6x plus 5. Okay, so in this case, what do we have? We have that a, what color shall I use for a? What color did I use for a up here? Oh, I didn't. Okay, so I claim that a, which is the coefficient of x squared, is 1, which is greater than 0, so I know that this is going to open upwards. I know that b, what color did I use for b? Oh, I used a bad color. So b, in this case, is a coefficient of x, so that's negative 6, and c is the constant coefficient, which is 5. So these together, from these we can find h and k. Let me change that to a different color. Maybe I should have made that. Yeah, let's make that purple. Okay, so what was h? H was negative b over 2 times a. So for us, that's going to be negative of negative 6 divided by 2 times 1. So I get that h, the horizontal translation, positive 6 divided by 2 is 3. We said that k was equal to, well, what was k equals to? C minus b squared over 4a, right? So c minus b squared over 4 times a to the first power. So this becomes 5 minus, so b squared is going to be negative 6 quantity squared divided by 4 times a, which is just 1. Okay, so we get 5 minus was, just making sure that it is b squared. AH squared, okay, got it. Okay, so what do we get here? We have 5 minus, well, 36 over 4 is 9, right? So that's going to be a negative 4. Okay, so I know my vertex. What color should I use? So vertex will be at h comma k, which for us is going to be 3 comma 9, negative 4. So h is 3 comma k is negative 4. So there's my vertex. I know I open upwards, so now I need to find my y-intercept and my x-intercept. So the y-intercept is easy. So the y-intercept is c. So y-intercept at 0 comma c, which is 0 comma 5. However, the x-intercepts we have to factor. So let's look at the function. So we have f of x is equal to x squared minus 6x plus 5, which we can factor as what two integers have a product of positive 5 but a sum of negative 6. So that would be negative 5 and negative 1. So x-intercepts at x equals to 1 and 5. Okay, so what does this mean? Let's actually draw this. I need to go down to negative 4. 1, 2, 3, 4. I need to go, oh, my y-intercept is 5. So what I'm going to have to do then is change the scale of this. I'm going to have to do a scale of 2. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. And I can make it a bit smaller now. 1, 2, 3, 4. So x and y. Okay, so my vertex is at 3 comma negative 4. So let's plot the vertex. Go to the right, 3 down 4. Vertex. I'm going to open upwards, but my x-intercepts are at 1, 3, 4, and 5. And I know that my y-intercept is at 5. So 1, 2, 3, 4, 5. Okay, so now I'm going to plot this graph. Nope, okay. Okay, it's supposed to autocorrect. Why is it not autocorrecting? There we go. Okay, that looks looks pretty good for this autocorrect business. Okay, so it opens upwards, and there we are. So notice that what we have at the vertex is a minimum at vertex. Okay, so hopefully this made sense. Let's do another one. So subscript number 2. So let's say we have that f of x is equal to 3x squared minus x minus 2. Okay. So once again, now a, in our case, is 3, which is greater than 0. So that implies that it opens upwards, this parabola. B, what color did I do B in? B, which is a linear coefficient, is -1. This is a -1 right there. C, which is a constant coefficient, is -2. So these together imply that H, which is negative b over 2a, can be written as negative of -1 all over 2 times 3. So this gives us a positive 1 over 6. K, on the other hand, was C minus b squared over 4a. Okay, so what does this give us? So C is -2. Then we're going to have minus. Did I do a minus there? Just making sure I did. Okay. B here is -1, which we're going to square all over 4 times A is 3. Okay, so what do we get? We get -2 minus 1/12. So that's 24, -25/12. So my vertex will be at h comma k, which for us is going to be at 1/6. So h is 1/6 and k is -25 over 12. It's terrible. 25 over 12. Okay, so where's my y-intercept? Well, my y-intercept will be at 0, c, which is 0, -2. And my x-intercepts I need to factor. So we have that f of x is equal to 3x squared minus x minus 2. So we do the x method. What 2 integers multiply to 3 times -2 is -6, and they add to the linear coefficient -1. Well, that would be, let's see, -3 and +2. Okay, so we rewrite f of x as 3x squared minus 3x plus 2x minus 2. Okay, so what does that give us? Maybe I should leave space in between each step. So I can factor out a 3 and an x, and what remains will be an x minus 1. Then from the second 2 terms, I can factor out a 2. What remains will be x minus 1. So I can now factor this as 3x plus 2 times the quantity x minus 1. And if we're setting this to 0, because we're looking for the x-intercepts, we know that this implies x-intercepts will be at x equals to 1 and negative 2/3. Okay, so with all of this, let's go ahead and plot this. So x and y coordinate axes, I know my vertex is at 1/6 to the right and about negative 2 and a little bit down. And I'm opening upwards. And what's my intercept? Negative 2. Okay, interesting. So it's very, very short. I really don't need all this. Oops. So x and y. So we have 1, 2, 3. 1, 2. 1, 2. 1, 2. Okay. So my vertex was at 1/6 and a little over 2. There's my vertex. My y-intercept, however, was at 0, negative 2. Oops. Oh, sorry. That's not 2. I'm doubling. Got to double. Forgot to double. Okay, so here we are. Little past. There we go. My y-intercept is at negative 2. And my x-intercepts were at 1 and negative 2/3. So about there. So it looks like my vertex could be just a little bit more. Ugh. Come on. My vertex could be a little bit closer, like so. Very close. Okay, so now if I were to plot my f of x, terrible. Guess I'll have to do this. No, why is it not autocorrecting? It's supposed to autocorrect. Come on. It was doing it before. Why is it not doing it now? There we go. Okay. Don't know what was going on. That a bit more like so. That's good. That looks better. And then I'm going to do the same thing. I'm just going to copy, paste this. Like, how far up did I go? To there. It needs to go through there. There. Okay. So this needs to be a bit. Like so. Yeah, close enough. Okay. So there we go. This is an estimate to what it should be. Good enough. Okay, so notice that the vertex is a minimum again, because I have minimum and vertex. Okay, let's see if I can do one more. Then 1, 2, 3. Then we'll go into a different subtopic. Okay, so let's have f of x be equal to, let's do a negative so it opens down, negative x squared minus x plus 6. Okay, so now in this case, we have that a, the coefficient of x squared, is negative 1, which is less than 0. So finally we're opening downwards. My B, what color did I use for B? Pink. Okay, so B, verdammt, is going to be -1, and C is 6. So these together imply that H, which is -b over 2a, will be the negative of -1 all over 2 times -1. So the negatives ones reduce, and we're just left with -1/2 for H. So K, however, is C minus B squared over 4A. So for us, that's going to be 6 minus the quantity -1 squared all over 4 times the quantity -1. So this is going to give us 6 plus, because we have a plus on top and a negative, so 2 negatives plus 1/4. So that's 25/4, which is a little over 6.25, right? So we know the vertex will be at H comma K, which for us is going to be, so H is -1/2 and K is 6.25. If we want to write it as a decimal, not sure I do, but what the heck, let's go ahead. Since it's a reasonable decimal, one that can be done in our heads. Okay, so we know that the y-intercept is at 0, C, which for us is 0, 6. So now the x-intercepts, we have to factor f of x. So negative x squared minus x plus 6, I claim is going to be negative the quantity x squared plus x minus 6. So I'm looking for 2 integers, which have a product of -6 and a sum of 1. I claim that's -2 and +3. So the x-intercepts will be at 2 and -3. Okay, so let's look at this. I know that my y-axis has to go up to 6, and we have to go down to -3, so once again I'm going to double things here. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so first things first, let's do the vertex first, shall we? So the vertex is at -1/2 and 6.25, so 2, 4, 6 and a little bit. And now I'm going to open downwards. My y-intercept is at 6. My x-intercepts are at +2 and -3. Okay, and that's really all I need. So now I can just draw a nice curve, if it'll autocorrect. Nope, come on. You can do it. Draw a nice curve for me. There we go. That's good. So copy, paste. Yeah, I guess I can move that down a bit. How does it look? No, no, no. Okay, much better. Okay, so there we are. This is now opening downwards. And so notice that the vertex now is a max. So max at vertex. Okay. So hopefully that makes sense. So let's consider. No, it's a terrible consider. Consider what do we have? Ax squared plus bx. So I claim I can factor out an a. So this will be a times a quantity, pardon me, x squared plus b over a. Remember, when you factor, you divide each term by what you're factoring out. And what I want is a perfect square. So want to get to arrive at a times x. Let's see, minus h quantity squared plus k. Actually, let me not do the plus k now. Let's just do this for the time being. So what is this? This would be a. If I expand, this is going to be x squared minus 2xh plus h squared. Wonder if I should introduce you to the want to find acronym. Okay. So if I wanted this to be the same, then I would need that negative 2xh was the same as b over a. So this implies that negative 2xh would be the same as b over a times x. So I can reduce the x's. So I get negative 2h is b over a. Which means that h divided by negative 2 would be negative b over 2a. Oh, funny. We should say that because what has h been this whole time? Negative b over 2a. So we already knew that. Okay, so where am I going with this? Well, let's go back to the beginning. So ax squared plus bx we can write as a times the quantity x squared plus b over a times x. But I want to add something now. I want to add h squared because I want to get to that parenthetical that I have over here. Okay, so I know that what I have b over a is already negative 2h. So x squared plus b over a x plus h squared. But whatever I add to one side of an equation, I have to subtract out. So if I were to distribute, I would actually be adding ah squared. So I need to subtract ah squared, so I'm not doing anything. Technically, I'm just adding 0. Okay, So what do we have? So now we have a times x squared plus b over a x plus, well, what is h squared? H squared is going to be b squared over 4a squared, right? We've done that before as well. And then on the outside, we're subtracting a times b squared over 4a squared. And we already know that the a's reduce because on the outside, that's really my k. We'll get to that in a moment. So this is a now times the quantity x minus h, right? Because that's a negative, minus h, or let me write it this way, plus b over 2a, quantity squared, minus b squared over 4a. Okay. So this is what we call completing the square. So we know that this would be x minus h, and this would be k in our regular equation. Okay, so let's consider completing the square, which is what we just did. Completing the square. Okay, so if you're given ax squared plus bx, then number 1. So factor, or actually, I can actually do plus c. Factor the lead coefficient, a, from terms involving x. We call those the variable terms. So step 2, so actually this would lead to what? This would lead to a x squared plus b over a x. And then the plus c would still be on the outside. Number 2, we're going to find half the resultant linear coefficient. So find half the resulting linear coefficient. Okay, so for us, that's going to be b over 2a. Because as it stands, it's b over a, right? Okay. Step 3. And we're going to square that result. So what that gives us then is b squared over 4a squared. Step 4. So add this inside the parentheses. And subtract the product of this and the lead coefficient on the outside. Okay, so for us, this will be a times a quantity x squared plus b over a times x plus b squared over 4a squared. Then we're going to subtract a times that, which is b squared over 4a squared, and we know that the a's will reduce on the outside. Okay, in fact, let me just go ahead and reduce them right away since we already know what the answer is. So this is going to be minus b squared over 4 times just a. Okay. Now step 5 is to factor the parenthetical. Factor the now perfect square. Perfect square trinomial inside the parentheses. Okay, so that's going to give us a times x plus b over 2a squared minus b squared over 4a. Okay. So, let's note and something interesting about that. So note this process changes. Well, what is the form a squared plus bx plus c? Is that the general form or the standard form? That's the general form, so it changes the general form. General form of a quadratic to the, well, this last factored form is going to be the standard form. Okay, so for example, so express the following quadratic expressions in standard form. So express the following quadratic equations or quadratic expressions rather. There's no equals, so it's not an equation. So expressions in standard form. And state whether the vertex and find the vertex. And of course, state whether it's a min or a max and why. So let's say we have 3x squared minus 6x plus 5. Okay, well, I claim that this is 3 times x squared minus 6x plus 5. So what I want to do with this is I want to factor the 3 only from the two terms involving x. So if I factor the 3 from the two terms involving x, this will be x squared minus 2x, and I still have the plus 5 on the outside. Okay, so now what I'm asked to do is to take half the linear coefficient. So I claim, and in fact, let me write the linear coefficient. Let me color code the linear coefficient, so minus 6 minus 2. So now semicolon. So we're going to take negative 2 and we're going to divide that by 2. Then, because we factored the lead coefficient, then we found half the resulting linear coefficient. And now we're going to square that. Step 3 is to square this. So negative 1 quantity squared is 1. So that's what I'm now going to add inside the parenthetical. So this is going to be 3 times the quantity, x squared, minus 2x. Now I'm going to add 1 inside the parenthetical. But if I do that on the outside, I need to subtract a, the lead coefficient, times what I added in. 3 times 1. So what this is going to give us then will be 3 times x minus 1 quantity squared, and 5 minus 3 is 2. So now this is in standard form, and we can read the vertex right off of this. So vertex will be at h comma k, which for us, oops, what the heck? What is going on? So for us, h comma k is going to be positive 1, because horizontal translation is counterintuitive, and 2. And I claim it's a max, a min, because a is equal to 3, which is greater than 0, so I know that it's a U shape, so it's a minimum. Okay, let's do another one, a couple more. So number 2, so let's say we have negative 2x squared. What am I doing? Plus 12x. Minus 3. Sounds good. Okay, so this is going to be negative 2 x squared plus 12x minus 3. So the first step is to factor the lead coefficient only from the terms involving x. So when I do that, I divide each term inside by a negative 2. So this now becomes x squared minus 6x inside the parenthetical, and I still have the minus 3 on the outside. At this point, I can take half of the linear coefficient, so negative 6 divided by 2, and then I square that result. 6 over 2 is 3, 3 squared is 9. So my next step is to add that inside the parentheses. So this is now negative 2 times x squared minus 6 times x plus 9. Okay, so what did I really do? I need to subtract now lead coefficient negative 2 times what I added in, 9. Okay, so what do we get? We get negative 2. This is now a perfect square trinomial. It's x minus 3 quantity squared. And I have negative 3 plus 18. So this gives us negative 2 times the quantity x minus 3 all squared plus 15. So I know my vertex will be at h comma k is 3 comma 15. Counterintuitive for horizontal and intuitive for vertical. Okay, and I know that this is a max because a is negative 2, which is less than 0. So that's an upside down parabola. So that's a max. Okay, let's do another one. So number 3, the final one, I think. Is that all I have? Yeah, that'll be all I have for this. So let's do 5x squared plus 10x. Okay, make it easy. So I claim this is 5x squared, oops, wrong color, x squared plus 10x. So first I factor the lead coefficient from all terms involving x, and in this case each term has an x, so this will be x squared plus 2x. Then I take half the linear coefficient and I square it. 1 squared is just 1, so that's what I add inside the parenthetical. So this will now be 5 times the quantity x squared plus 2x plus 1. But I need to subtract lead coefficient times what I added in on the outside. So what does this give me? This gives me 5 factoring this perfect square trinomial is x plus 1 quantity squared minus 5. Okay, so my vertex will be at h comma k. Remember, counterintuitive for h, so that's negative 1, and intuitive for k, so that's negative 5. And I know that this is going to be a minimum because a, which is 5, is greater than 0. So I know it's a U shape, so that's a minimum. Okay, I hope this made sense, and I'll see you in the next video.